Hi, good morning, everybody. Welcome to our science class. In the previous class, we completed a separation of soluble solid from liquids. Here, evaporation and distillation both we completed, and how why distillation is used, where we use that also completed. Next, we'll go to the fourth point, page number 54. All of you take, okay? Page number 54. Fourth point, separating a mixture of two liquids. Separating a mixture of two liquids. How we can separate a mixture of two liquids? That's all. Okay. Liquids that are soluble in water and form a single layer with water are said to be miscible in water, whereas liquids that are insoluble in water and form distinct layer are said to be immiscible in water. All liquids are will not mix with water. Mixture means liquids which are miscible with water are called miscible liquids, and which are not miscible, that immiscible, we'll say. Okay. We'll go again. Separation of miscible liquids. How we can separate the miscible liquids? Fractional distillation. Okay, here we using fractional distillation. Similar to simple distillation, fractional distillation is best for separating a solution of two miscible liquids. This method takes advantage of the different boiling point of the two liquids. For example, alcohol has a lower boiling point than water. Then heat it boils first. The vapors of alcohol rise, flow through the condenser and gets collected distillate. The water with a higher boiling point remain in the flask. If alcohol mixed with water, how we can separate it? That here explained. Okay, alcohol has very low boiling point, okay, than water. Then if we heat it, no, first alcohol will evaporate, water will remain there, stay there. Then we will boil it it is 60-70 degree, like that. Alcohol will convert into water vapor. It will not heat more. In minimum heat it will keep. Then automatically alcohol will convert into water vapor. We can separate it and water will remain there. Okay. That way we can separate alcohol from water. Okay, next one, separation of immiscible liquids, separating funnel. How we can separate immiscible liquids? Two immiscible liquids can be separated from each other using the separating funnel by taking advantage of their unequal density. Their density will be different, because due to that, now we can separate it. Oil and water are immiscible liquids. They can be separated by using a separating funnel. The mixture of immiscible liquid is poured into a separating funnel fixed on a stand. The mixture is left undisturbed for some time. The heavier liquid water settle at the bottom. The stopcock is opened and the liquid in the lower layer is collected. As soon as that liquid is collected, the stopcock is closed. The next liquid is collected in other vessel. Okay, liquid of oil and water. Here we will pour it into a funnel, then automatically what will happen, the heavier liquid will stay down and weightless one will go up. Then after that we will keep it few minutes, okay, without disturbing. Then automatically heavier liquids will be down, and which liquids has less weight, it will be remain upside. Then from the upside we will remove it, we will pour it, or with one pipe we will remove it. Then water or heavier liquids will be remain downside, okay. In oil, water is heavier, then water automatically will settle down and oil will come upside, okay. You can check it, okay. Funnel means just tube, like a long burden or something need, okay, just like test tube, okay. Then will be easily we can separate it. Separation using more than one method. We have studied some method for separating of substance from their mixture. Often one method is not sufficient to separate the different substances present in the mixture. In such a situation, we need to use more than one of these methods. Let us understand these with the following example. To separate a mixture of iron fillings, sand and common salt, now we will use different methods to separate the constituents of the mixture. Removal of the iron fillings, okay. Different things are mixed, then how we will remove it, okay. To separate mixture of iron fillings, sand and common salt, three things are there, okay. Iron fillings, sand and common salt. How we will remove it? Removal of iron filling. First we will remove from this mixture, first we will remove iron filling. Generally you know that early we learn, with the help of magnet we can remove iron filling. See, separate the mixture of the on a paper and roll a powerful horse magnet, shoe magnet on it. Scrap of the iron fillings from the magnet in a china dish. Separate the process until no iron fillings are left in the mixture. Okay, this mixture means iron, sand and common salt mixed, that we will scattered on a paper or somewhere, and after that with the help of this magnet we can remove the iron filling very easily, okay. Which method is used there? Magnetic separation we use there, okay, remember it. Next one, removal of sand. How we can removal of sand from the salt? Again salt is there, dissolve the mixture in water. To remove the salt and sand, first we will pour their water. Then what will happen? The salt dissolve in it, but the sand does not. If we pour water there, their sand and salt is there. Automatically salt will melt and mix with water, but sand will not dissolve with the water, but the sand does not. And filter the mixture, the sand is left on the filter paper. The clear common salt solution is collected as a filtrate. Wash and dry the sand. That filtration we use there, okay. If we chalni और कुछ use करने से क्या होगा? Automatically the salt water will go down and sand will remain on the filter. Then just will wash and that sand will take out sand. That way we can separate. Then two things we separated. First iron we separated. Now sand also separate. Again what is remaining there? They are remaining salt only. Yes, no, salt is already mixed with the water. That through evaporation we can remove it, that also we learn. Third point, okay, transfer the filter into a beaker and heat it over Bunsen burner. In a few minutes, water evaporates, uh, leaving heavy behind the common salt. Automatically, what will happen there? Water will evaporate and common salt will remain there. Okay, which method we use there? Evaporation. Okay, so we have used three different methods to separate a mixture of iron filling, sand, and common salt. Which are the three methods we use there? First, we use the magnetic separation. Next one, filtration. Third one is evaporation. These three methods we use there to separate these three mixture. Next one, solution and solubility. A solution is a homogeneous mixture compound of two or more substances. A solution has two components. A solution has two components. The substance that is dissolved is called solute. The substance that dissolve, which one is the dissolved? That is called what? Solute. And the substance in which solute is dissolved is called solvent. Generally water and all, okay, solvent. And the resulting mixture is called a solution. A solute plus solvent, then solution will get. Okay, downside you look. Okay, this solute plus solvent is equal to what will get? Solution will get. For example, salt is a solute and water is the solvent, and salt solution will form there. Next one, sugar is the solute there, and water is the solvent. All of you remember. Okay, what is solute, what is solvent, both you remember it. Okay, and sugar solution will get. Okay, and sand plus water. Sand is the what we can say solute, and water is the solvent, but no solution because sand will not mix with the water. Okay, today this much enough. All of you study well. Okay, read the textbook well. Okay, then bye.